So we're on 6.9, which is logarithms with other bases. So find 6.9 in your packet. So far we've talked about taking logarithms with a base of 10. So now we're going to talk about logarithms with bases other than 10. Okay. If it has a base of 10, we call it a common log. So I'm going to write this in here, a common log. Okay. And that's something like if you have a power with a base of 10, 10 to the x equals some y, and we want to write that as a log, well, then we would write the log with a base of 10. The base goes down here, of y equals your x value. Okay. Now, the tricky thing about this is if it is a common log means the base is 10. You don't put the base down there. Okay. It's so common that it's kind of like with the square root. We don't put the little 2 as the root index because it's so common to be a square root that we just assume if there's nothing there, we assume it's a square root. Here we're going to assume this is a log with a base of 10. Okay. Now to write logs with other bases, so if you have anything in exponential form, I'm going to write my power b to the x equal to y. Okay, this entire thing is a power. Just a reminder, this entire thing is the power. The b is the base. And the x is the exponent. Okay, so b to the x equals y. If I'm going to write that as a log, well, then it's going to be a log. The base of my power is b, so my base is b, and I write the b down here below the log. It's almost like you've got this invisible line here. The b goes down below, and then you're taking the log of y. So we'd say log base b of y is equal to x. Okay, and as you can see, when you take a log of a number, and then you specify the base down below, log of a number, what you get here is your answer, or it's really the exponent. It's the exponent when your power is written in exponential form. Okay, so sometimes you'll hear that a log is simply, let's write it this way, a log of a number. So the log of y, the log of a number is an exponent. Okay, so the log of a number, the log of y, is the exponent you would have to put on the base to get that number. Let me say that again. The log of y is your entire power over here. The log of that power, you specify the base, it's the exponent over here that you would put on that base to get y. Okay, so let's look at some examples. This now is just notation. Log base 4 of 256 equals 4. So I'm going to keep saying it the way that you say a log, because it's really important to understand how you're saying it, to say you're saying it right so that you can understand what you're doing. It's log base 4 of 256 equals 4. So the log is the exponent. 4 is the exponent I would have to put on this base over here to get the number 256. So I start with the base down here, log base 4 of 256. I go over to the other side of the equation because the log of the number is the exponent. So this base raised to this exponent is equal to this thing, which we could call the answer or the argument of our log expression, equals 256. Okay, let's get used to doing that. This is the log base 12 of 1 over 24 equals negative 2. So the log of this number is this exponent. That's the exponent I would have to put on this base to get this number. So my base is 12. Go to the other side of the equation. For the exponent, 12 to the negative 2 is equal to this number, or the argument of like my log expression. So 1 over 144, which we know is correct because 12 to the negative 2 would be 1 over 12 to the positive 2, which is 1 over 144. Okay, so here, notice there's no base written. This does not mean the base. The base has to be written down below. If there were a base, you'd see it down here. And since we don't see a base, it's a common log, and we assume the base is 10. Okay, so my base down here is a 10. Raised to the first is equal to my argument of 10. Okay, now we're going to go the other way. Write each equation in log form. Notice we're not solving anything. We're just going back and forth between log form to exponential form. Now these we're going to go from exponential form to log form. So log form, we're always going to write log. This is my power. The base is 8, the exponent is 3. So my base of my log expression is going to be the base of the exponential expression. So log base 8, that goes down below, of 512. So 512 goes right next to the word log as if there were a line there. The 8 goes down below. Log base 8 of 512 equals 3. And if you can remember, the log of a number is your exponent. This 3 has to be on the other side of the equation by itself. That's your exponent. Okay, so here we've got log. And when I kind of wrote that line, you don't write that line there. That's just to show you that the base goes below. So this is a log base 10 of this number is equal to -4. Okay, now again, when the base is 10, it's a common log, so we don't really put that there. It's not really proper notation to put that there. It's kind of redundant. Okay, but the log of the number is my exponent. The log of this number is the exponent I would have to put on this base of 10 to get this number. Okay, this one over here, we'd have log. The base of my exponential expression is 25, so log base 25 of 625 is equal to my exponent 2. Okay, and what are the restrictions on the definition of log base a of y? Well, the restrictions are that your base, here your base is a, must be greater than 0. Okay, you can't have a negative base, and it doesn't make sense to have a base of 0, so it must be greater than 0. Also, your base, I'm going to say your base, I'm so used to writing b for base, but our base here is a. So a also cannot be 1. Kind of doesn't make sense to have an exponential expression with a base of 1, because 1 to the anything is just 1. Okay, and then the last thing is that the y value has to be greater than 0. You cannot take a log of a negative number. Okay, now down at the bottom, we're going to do some practicing. And here we're actually finding x. We're solving for x. So we're going to get used to going back and forth between log form and exponential form. And then you're going to solve, you're going to get it into an equation where you can actually solve for x. Okay, x equals log base 2 of 16. My base is 2 of my exponential expression. My exponent is over here. 2 to the x is equal to 16. Okay, now this is pretty easy to solve. If you recognize 2 to the what is 16, well, it's 2 to the 4th. If you didn't recognize that, hopefully you know your powers. 16 is 2 to the 4th. So if you have 2 to the x equal to 2 to the 4th, the only way those powers are equal to each other, since the bases are the same, is when the exponents are the same. So x has to equal 4. Okay, this one, start with your base. This is x equals log base 3 of 1 over 27. My base is 3, so when I change it to exponential form, my base is 3. I go to the other side of the equation for the exponent. 3 to the x is equal to my argument of my log expression, 1 over 27. Okay. Now, you might recognize what you would have the exponent you put on a 3 to get a 1 over 27. But we could try to get this thing into a base of 3. So 3 to the x equals, and I know that's 1 over 27 is 3 cubed. Okay, I'm going to come over here. So 3 to the x is equal to, if I want to bring this power to the top, that becomes 3 to the -3. Now I have two powers with the same base, so their exponents must be equal. So x has to equal -3. Okay, this one I've got my x equals log base 81 of 9. 81 is my base. Go over here, 81 to the x is equal to 9. Now here we could get these into the same base pretty easily. 81 is 9 squared. That's my 81. My 81 is raised to the x. Power of a power, you multiply the exponent, so 9 to the 2x equals 9. Now we have two powers with the same base. The exponent here is just 1. 9 is equal to 9 to the first. So now I can set the exponents equal to x must equal 1, and then x is 1/2. Okay. Next question. That's going to be log base x of 1 over 25 equals -2. So I start with my base of x raised to the -2 is equal to 1 over 25. Okay, couple ways to do this. One way that we can do this one, x to the -2. Well, if you recognize 1 over 25, 1 over 25 is 1 over 5 to the +2. If I want to bump that to the top, that's equal to 5 to the -2. So I've got x to the -2 is equal to 5 to the -2. So if my exponents are the same, the only way this works is if this base is also 5. So you get x equals 5. Okay. There is another way to solve this one, and I'm going to show you on this one, because this one is a little bit harder. Your base is x. Log base x of 8 equals 3/5. So base is x, x raised to the 3/5 is equal to 8. Okay. So I have x to the 3/5, but what I want is x, which is x to the first. So I can take both sides of this equation and raise them both to the x to the 3/5. Remember, when you raise a power to another power, you multiply the exponents. So if I want to raise this to another power, I want to raise it to something where when I multiply the exponents, I'm just going to get 1. So 3/5, if I raise that to the 5/3, I'm going to get x to the first, because 3/5 times 5/3 just gives you 1. And then on this side, I've got 8 raised to the 5/3. Okay, it's usually easiest to simplify this when you get that to the smallest base possible. So 2 to the 3rd is how I'm going to write 8. That's going to be raised to the 5/3. Notice this 2 to the 3rd is just my 8 right here. So this 8 has this exponent, so this 8 has to have this exponent. Now, power of a power, multiply your exponents. 2 times 5/3 is just 5, so I've got 2 to the 5th. So now putting it all together, this thing we just said was x to the first, which is x, is equal to this, which is 32. Okay. Next one, x log base x of 1 equals 0. X to the 0 equals 1. X to the 0 is equal to 1. Well, and pretty much anything to the 0 is equal to 1, as long as it's a positive number. Okay, so you're going to get x can equal any positive number. Okay. Okay, now down to the next one. Log base 1/8 of x equals 2. So my base is 1/8 raised to the second is equal to x. Okay. 1/8 to the second equals x. So you could just square 1/8 and you get 1 over 64. Okay. Next one, log base 7 of x equals -2. My base is 7 raised to the -2 is equal to x. So that's equal to 1 over 7 to the +2, or 1 over 49. Okay, and the last one, 8 over 27. So I've log base 8 over 27 of x equals -2/3. So that's 8 over 27, my base, raised to the -2/3. equals x. So we've got the x by itself, so now it's just a problem where we're simplifying. We're simplifying this expression. So let's get 8 over 27 to the smallest base possible. 8 is 2 cubed, and 27 is also a perfect cube. So I can write 8 over 27 as 2/3 to the third, because 2 cubed is 8, 3 cubed is 27. There's my 8 over 27. My 8 over 27 has an exponent of negative 2/3. So 2/3 raised to the third raised to the negative 2/3, a power of a power, multiply the exponents. So I've got my 2/3. When I multiply 3 times negative 2/3, the 3's cancel. I just get 2/3 to the negative 2. Okay, if I want to make this negative exponent positive, it becomes, I can move the 2 down to the bottom, the 3 up to the top. And that's now raised to the positive 2. Now that's just 3/2 squared, which is going to be 9 over 4. That's my answer for x. All right. Hope you enjoyed the video. Thank you for